All right, we're back for the second portion of our video on section 10.2, which is measuring angles and arcs. Today we're going to focus on the actual arc length formula and solving with a few examples. I'm just hanging out here in my yard with my friend, one of my guineas. Let's get started into the notes. So I'll share my notes with you here. We have a few definitions that we have to fill in for this one. So the first one is, what is an adjacent arc? We've talked about adjacent angles before, so this shouldn't be too much of a stretch. Adjacent angles were angles that were next to each other that didn't share any interior points. Adjacent arcs are the same thing, right? They're arcs in a circle that have only one point in common. So they have one point in common, that's it. They're next to each other, right? They come together at one common point. Adjacent arcs. There's an arc addition postulate, very similar to all of the other addition postulates we've done, segment addition, angle addition. Now we have arc addition. Arc addition is just the measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So I have this diagram here to kind of illustrate both of those things. Right? I have circle M, and in circle M, it says that arc HJ and arc JK are adjacent arcs. And you'll notice that if I have this arc here, HJ, this arc here, JK, they're arcs next to each other with one common point together, that is point J. Now, if I want to use that arc addition postulate with those same two arcs, if I take HJ, arc HJ, and I add arc JK, it should make sense that that would give me the measure of the entire arc HJK. Right, so the measure of arc HJ plus the measure of arc JK should give me the measure of arc HJK. Arc addition postulate, not too bad. Now to the heart of this section about arc length. It says arc length is simply a distance between the endpoints along an arc measured in linear units. Right, it is simply a fraction of the circumference. So circumference were measured in linear units. Right, whether it be feet, centimeters, inches, what have you. Arc length is measured in the same way because it's just a part of that circumference. So as you're traveling around this circle, the entire distance around is the circumference. Part of that distance is called an arc length, the length of one of the arcs. Right, when you refer to arc length, they denote it with this kind of cursive L. Right, so that there is the arc length symbol. And the formula is x over 360 times 2 pi r, where x is an arc degree measurement. Now, I think this should make sense, and I think we could have probably derived this formula on our own if we would have thought about it. The entire circumference is 2 pi r, right? So if you just take this part of the formula, that's just circumference, 2 pi r. If you take x over 360, that's a portion of the circle, right? What portion of the circle do you want? So for example, if you did 90 degrees, well, 90 degrees would be a fourth of the circle because 90 divided by 360 reduces to a fourth. So if I want the measurement around the outside of a fourth of the circle, it should make sense that it's a fourth of the circumference, right? Which is what this formula tells us. So I have an example down here at the bottom that I already have worked out. It says in circle D, AC is a diameter. Find the length of arc BA, leave in terms of pi. So once again with these answers, they'll either tell you to round to the nearest tenth, nearest hundredth, what have you, or they can just say leave in terms of pi. They say leave in terms of pi, right? That pi will show up in your answer. You don't have to type it into your calculator. So for this one, if I'm trying to find this arc length BA, right? BA is right here. That's a 40-degree central angle, which means the arc measurement will have a 40-degree measure as well. So my angle is 40 out of the total 360. Multiply it by the circumference, 2 times pi times r, and the radius they gave me over here is 4.5. So 40 over 360 reduces. It reduces down to 1/9, right? 4 goes into 36 9 times. The zeros will cross out, divided by 10. So I'm down to 1/9. 2 times 4.5 is 9. So I have 1/9 times 9 pi. The nines will also cancel out, and I'll be left with pi. Now the radius was measured in centimeters. Therefore, my arc length also measured in centimeters. So that's the arc length formula. I do have a few more examples if you would like to go through a few more. So for these, it says find DC, right? The length of DC, and this one says to the nearest hundredth. So if I'm trying to find DC, I see that it has a 28-degree angle, central angle. So therefore my arc measure will be 28 degrees as well, same as the central angle. So 28 out of the full 360 times the circumference 2 pi r, where the r is 6. I get 28 over 360 reduces to 7 over 90. 2 times 6 is 12. And then I'll just plug that into my calculator because this one wants to the nearest hundredth, and I'll get 2.93 centimeters for that arc length. And then for our last example here, this one says leave in terms of pi. Find the length of arc DA. Well, DA, they didn't actually give us a measurement for the angle, right? They gave us DC's central angle as 40 degrees, but they didn't give us this ABD angle measure. However, I know that AC is a diameter. Diameters create semicircles. Semicircles are 180 degrees. Straight lines are 180 degrees. So if this is 40, this would have to be 140. Okay, my pen is dying there, so that's 140 degrees. And if that's 140 degrees, then I can take that divided by 360 times 2 times pi times r, where r again is 6. And then 140 over 360 reduces, and I can multiply that by 12, reduce it again, and I'll get all the way down to 14 pi over 3 centimeters. Remember, this one says leave in terms of pi. All right, so adjacent arcs, arcs that are next to each other with only one point in common. We had the arc addition. If you take two arcs and add them together, you get the larger arc that they create. And the arc length formula will take the circumference 2 pi r times the portion of the circle we want, the angle divided by 360, giving us our arc length. Just make sure you read the directions. Be careful, as I say, leave in terms of pi, round to the nearest tenth, nearest hundredth, whatever. And make sure you label them with your units, right? These are linear units, centimeters, feet, inches, yards, whatever it may be, but make sure you put the label on it. So that's going to be it for this video on 10.2. That's it for arcs and angles. And make sure you like, subscribe, and comment. Helps out the channel a lot. And we will see you next time.